Hi students, my name is T. Rashekar, working as a lecturer in civil engineering, SRS Government Polytechnic Sicily. First year, first sem, I am going to teach the subject of basic surveying. The subject code is CE105 and the chapter name is Compass Survey. So today we are going to see the topics on local attraction, detection, correction, included angle method. Objectives: on completion of this period, you would be able to understand what is local attraction and how it is affected to the compass surveying station points. So why this local attraction will be happen in the compass surveying? So for every instrument there will be some effects. So therefore we are seeing the errors in instruments. That is one of the fault. So in the previous videos we have discussed regarding the errors in chain. So why these errors are occurred in the chain? Due to the personal, natural, okay, and as per the instrument. So here chain is an equipment, okay. So due to the atmosphere changes and effects, and while pulling the chain it will be gets loosened and the rings will be damaged. So many problems will be occur at the chainage usage. So for chain we will have some problems and errors, and meanwhile you see the compass also have the errors. So to detect that error we are following the using the certain methods, that is included angle method and exterior angle method. So to find the local attraction and rectify it, we are using the bearings method also. So actually, what is local attraction? And you see here, detection of local attraction. So how to detect the local attraction, we will find out it. And next, sources of local attraction. Why this local attraction occurs? And elimination of local attraction by solving the problems. Okay, so we will have the some of the examples regarding the local attraction problems also. Okay, so generally this local attraction is very important topic in the our compass survey. So we will have the some example problems also on this local attraction. Okay, so this due to this local attraction our instrument faces the some of the problems and errors. So how to detect that and how to rectify and how to correct it, we will using the some of the local attraction problems. Okay, so let us see here. In the previous classes we have learned that how to take bearings in the field and how to conduct compass traversing. Okay, and we have seen the how to calculate included angles also, that is 2n minus 4 into 90 degrees. Okay, 2n plus 4 into 90 degrees, exterior included angles method. So first of all, let us see the local attraction definition. So the local attraction is very important. Local attraction is the term used to denote any influence which prevents the magnetic needle from pointing to the magnetic north in a given locality. So whenever you fix the instrument on the ground, okay, with the tripod stand. So you have to observe the certain things nearby you. So why this local attraction will be occurred, that is, we have to observe one thing. In the local attraction is occurring due to the some of the effects due to like magnetic instruments. So you have to observe here the magnetic needle is there. In the compass instrument we have the magnetic needle. So this magnetic needle, it will be attracted to the iron items. Okay. However, we see if you take the magnet, okay, if you keep in the ground also, some of the magnetic particles will be attracted to that magnetic. So why these are attracting? That is the force which repels the magnetic power. So meanwhile, you can see iron is the main force to attract it. So meanwhile, you can see whatever the magnetic items are there nearby the compass instrument, so those will be repelling the, that means moving the magnetic needle automatically. So if you are sighting any object nearby, you should not keep any iron particles or any iron items. So if it is there, it will be attracted to that item and we will be getting the not actual measurement, we will be getting the bearing in difference or we will get error. So that's why we are defining that is not local attraction is the term used to denote any influence which prevents the magnetic needle from pointing to the magnetic north in a given locality. So this is the regarding the local attraction definition. So now let us see the sources of local attraction. So the sources which attract the local attraction are iron ore, magnetic in ground, okay. So iron ore, you have can see main iron particles should not be just like iron telephone towers or any electrical lines, okay, electrical pole, okay. And coming to our personal items, watch, okay, you should not keep any pen, okay. So belt, so these are also should be available, chain. So these are all the magnetic particles which will be attract. And next, cables carrying electrical current. Under the electrical current wire, we should not keep this compass. If you keep this compass instrument under the electrical wires or near the electrical current wires, you cannot get the correct readings. It will be rotating and it will be getting the error zone. Okay. So that's why we have to keep in the very nice place whichever the magnetic particles are not there. And next, steel structures, railroad rails. We should be far away from the steel structures like steel bars, steel frames, steel shutters, windows, iron doors, whatever are there. We have to, and railroad rails, railway tracks. Okay. So regarding these, we have to be far away. So that's why the compass surveying is very sensitive to do. So in order to avoid all the things, we have to keep these all things in the mind. And next is underground iron pipes. So in under the ground, whichever the iron pipes are going, so they will also be attracted by the compass. So that's why we will call these all things local attraction. The attraction which is attracted from the local particles which are iron, magnet, cables, carrying electrical current wires, steel churches, railroads, underground iron pipes, water pipelines, whichever are there, these are all called the local attractions. And the keychain also, bunch of keys, axes, chains, steel tape also should not be near us. So each and everything will be attracted by the local attraction. So how to detect the local attraction? So let us see here, that is, find the difference of forebearing and back bearing of a line. So how to find out the taken measurements are not affected with local attraction? So that we have to find the difference by calculating the forebearing and back bearing of a line. And next, if the difference of forebearing and back bearing of a line is 180 degrees, then both stations are said to be free from local attraction. So remember this point. Okay. So here, if the difference of forebearing and back bearing of a line is 180 degrees, okay, then both stations are said to be free from local attraction. That means they are not affected with local attraction because they are within the 180 degrees angle. Suppose if the difference of forebearing and back bearing of line is other than 180 degrees, okay, suppose it is forebearing and back bearing of line is other than 180 degrees, then the stations are affected by local attraction. So that means whatever the readings you are getting by taking the compass surveying measurements, if it is not matched within the 180 degrees, so it is more than 180 degrees, our compass station is affected with local attraction. So then we have to know there is an error in that station point. So in order to rectify that, we will be doing the certain methods problems. So first of all, this point we have to keep in mind. Okay, if the station does not affect the local attraction, then the calculations will be easy to do. So if the station is affected with local attraction, then only the calculations will be more. Okay, so this point we have to keep in the mind, that is, if forebearing and back bearing of a difference of a line is 180 degrees, then both stations are said to be free from local attraction. Okay, if the difference of forebearing and back bearing of a line is other than 180 degrees, then the stations are affected by local attraction. So these points we have to keep in mind. So now let us see correction for local attraction. Just now we have seen how they will affect. Now we have to see how to correct the local attraction. So we are having the two methods for correction of local attraction. One is by calculating the included angles at the affected stations. So here, by calculating the included angles at the affected stations, that means wherever the affected station points are there. So as we know, if more than 180 degrees, it is affected. If it is forward bearing and back bearing is equal to 180 degrees, so there will be no affected. Okay. So when it is affected only, so we have to calculate the included angle method at the station points. Then next, by calculating the local attraction of each station and applying the required correction starting from the unaffected station. So that means whatever the, by calculating the local attraction of each station, okay, of each station we have to calculate it and apply the required correction wherever the forebearing and back bearing was affected, that is starting from the unaffected station. So that means wherever the affected station is there, from that we have to do to the all the points. This is the correction for local attraction. So first of all, see method 1, elimination of local attraction by included angle method. So suppose in case of closed traverse, so you know how the closed traverse is said. So this is the our closed traverse. So we can see the diagram. So this is the diagram. So a closed traverse will be totally with closing area. Okay. So in closed traverse area, compute the included angles at each station from the observed bearings. So that means we have to check the each station point, okay, and we have to include angle we have to find out from the observed bearings. And starting from the unaffected line, run down the correct bearings of the successive lines. So wherever the starting point which is affected, so we have to correct the other bearings of the successive lines. This is the method 1, elimination of local attraction by included angle method. So next, let us see a problem. So a closed compass traverse ABCD was connected and the foreign bearings were obtained. Determine which of the stations are affected by local attraction and give the values of the corrected bearings. So here a closed compass is given the 4 bearings, that is ABCD. So once connected and foreign bearings were obtained, so we have to find out which of the stations are affected by local attraction and we have to give the values of the corrected bearings. So let us see here. It has given there are 4 station points: line, 4 bearing, back bearing. Line AB in 4 bearing 74 degrees 20 minutes and in back bearing 256 degrees 0 minutes. Whereas coming to the BC, 107 degrees 20 minutes and in B back bearing 286 degrees 20 minutes. And in CD, 224 degrees 50 minutes and in CD back bearing is 44 degrees 50 minutes. Coming to the DA, 306 degrees 40 minutes and back bearing 126 degrees 0 minutes. So let us draw the diagram first. You can see here the diagram was shown in the display. That is, the first one is 74 degrees 20 minutes. Okay, it is the station point AB. So this is the first point A. So from here it is started to the point that is in the first quadrant, 74 degrees 20 minutes. Okay, it is started to the point B. So again draw the line north direction. Okay, so A to B is 74 degrees 20 minutes and now here B to C is 107 degrees 20 minutes. So again from B it is 107 20 minutes, it is in the second quadrant, so that means this quadrant. So draw again from here to C. Okay, so 107 20 minutes was the 4 bearing of BC and again from CD. So CD, how much it was given? 224 degrees 15 minutes. So it is in the third quadrant. Okay, so it is in the third quadrant. So 224 degrees 15 minutes was forwarded to the C. Okay, and now from DA we have the another forward bearing, that is 306 degrees 40 minutes. So from C here, this is the 306 degrees 40 minutes. So from here it is D to A. So like this, first we have to draw the diagram compulsory for the every question. So if you draw the diagram only, we can understand how many station points are there, whether it is a closed traverse or open traverse, and how many areas are affected with local attraction. So that can be rectified easily. And the next one is back bearing. So let us see the back bearing. So for AB, the back bearing will be AD 126 degrees 0 minutes. So that means this is the back bearing of AD. So here it will goes to how much the reading is there, 126 degrees 0 minutes. So from here it will go start. So in this bearing it will be there. So it will be at second one. So this will be the how much? 126 degrees. 126 degrees 0 minutes. This is the back bearing of AD. Okay, that is nothing but DA. And next, so it goes first this one, and the next BC. So for BC, let us see here. Okay, so for AB, again it will be going C back to the. So for next here, AD is completed. Okay, and next you can see 256 degrees, that is of BA. So from here it will be there. So in this quadrant it will be starting, that will be the back bearing. So this is the one example I have shown here. So like that we will get back bearings of BA, CD and DC. Okay, now let us find out the here the local attraction. So on observing the above bearings, we find that the forward bearing and back bearing of line CD differ exactly by 180 degrees. That means the forward bearing and back bearing of line CD, which are less than or equal to directly 180 degrees. Therefore, the stations C and D are free from local attraction. So why C and D are free from local attraction? Once check the diagram. So this is the C and you can see D in the CD. Okay. So if you observe 107.20 degrees is less than 180 degrees and 44 degrees 50 minutes is less than 180 degrees. So that means here C and D station points are free from local attraction. So hence here, therefore the observed bearings at station C and D are correct. Okay. So the observed forward bearing of line CD is equal to 224 degrees 15 minutes. So we have to start from the corrected bearing, that is the line CD. Okay, it is given how much? 224 degrees 50 minutes. So this one is the 224 degrees 50 minutes. So from here again back bearing of line BC is equal to 286 degrees 20 minutes. So for back bearing how much it is given? 286 degrees 20 minutes. So this is the back bearing. Okay, so back bearing of CB. And next, so back bearing of line CD is equal to 44 degrees 50 minutes. So in CD, that is back bearing was given 44 degrees 50 minutes. So for forward bearing of line DA is equal to 306 degrees 40 minutes. So and correct. So here that means stations C and D are free from local attraction. So these stations which are there 44 degrees 15 minutes and here 306 degrees 14 minutes, these are free from local attraction. So stations A and B only are affected by local attraction. So let us start calculation of interior angles. So see here, interior angle at A is equal to back bearing of line DA minus forward bearing of line AB. So first we have to do the back bearing and next we have to do the forward bearing. So the back bearing of line DA is, that is 126 degrees 0 minutes, whereas forward bearing of line AB is, that is 74 degrees 20 minutes. So then you will get 51 degrees 40 minutes. So here we have started from the calculation interior angle at A, that is back bearing of line DA. Okay, so where is the back bearing of line DA? This is the point, back bearing of line DA. Okay, so back bearing of line DA minus forward bearing of BA. So we have to check this one compulsory by seeing the diagram. Okay, so we will get the answer is 51 degrees 40 minutes. So let us check another at interior angle at B. So in interior angle at B, what was the reading was given? Here, back bearing of line AB minus forward bearing of line BC. So after calculation of interior angle at A, so now we have to calculate the interior angle at B. So we have to calculate the each and every point where the local attraction is not affected of corrected bearings. Okay, this we have to keep in the mind. So here the back bearing of line AB is 256 degrees 0 minutes, whereas forward bearing of line BC is 107 degrees 20 minutes. So then you will get the answer is 148 degrees 40 minutes. So this is the interior angle at B. So we have calculated the interior angles at A and interior angle at B. Okay. Now let us see the interior angles at C is equal to back bearing of line BC minus forward bearing of line CD. So obviously the forward bearing was given and the back bearing was given in the table. Okay. So the back bearing of line BC it is goes to 286 degrees 20 minutes, whereas in the forward bearing of line CD that is 224 degrees 50 minutes. So if we calculate this, we will get 61 degrees 30 minutes. So this is the interior angle at C. Now interior angle at D is equal to So we have to check finally, that is 360 degrees minus FB of line DA plus back bearing of line CD. Okay, so that means now we have to take from the 360 degrees, that is 360 degrees minus 306 degrees 40 minutes. Why we are doing with 360 degrees? Because it is nearer to the 360 degrees, that is 306 degrees 40 minutes. So back bearing of line is plus. Why? Because if you do 360 minus 306, we will get very less value. Okay, so that's why we have to have 44 degrees 50 minutes, then you will get 98 degrees 10 minutes. So this is a problem, generally calculation of interior angles. So therefore then we have to do sum of interior angles is equal to 51 degrees 40 minutes, 48 degrees 40 minutes plus 61 degrees 30 minutes plus 98 degrees 10 minutes. Then we have to get 360 degrees 0 minutes. So this is the answer we have to get exactly and correctly. So that is done by doing the correction in inclined angle method. So in this step, the inclined angle, the problems will be there. So here we have to observe where the local stations are affected. So next we have to apply the arithmetic check, that is 2n minus 4 into 90 degrees. So this is for the inclined angle method. So if you do this one, we will get 360 degrees. So this is the arithmetic check, because to check the 360 degrees angle. So generally we have to observe everything, that is forward bearing and backward bearing were given in the station points. We have to check in the table itself. So in the table itself we can do the everything, that is 74 degrees 20 minutes minus 256 degrees, we will get some value. Okay, then 107 degrees 20 minutes minus 286 degrees 20 minutes, we will get one value. So 224 degrees 50 minutes minus 44 degrees 50 minutes. Meanwhile 306 degrees 40 minutes, we will get. So in these cases, this type of problems will occur. Okay, so let us see here once again, that is, so in forebearing and back bearing, these errors are occurred, and the diagrams should be shown on the paper. So for this calculation of interior angles, we have to start with the corrected points. So like this, A, B, C, D, we have to calculate the interior angles, and after that we have to check whether the all angles are getting in 360 degrees or not. So here 1, 2, 3, 4. The station points are which are 4 in the closed traverse. It is 360 degrees. Suppose it is more than 1 plus 5, we should get 540 degrees. That is for the pentagon shape. Okay. So let us see the calculations for corrected bearings. So now whatever the corrected bearings are there, we have to check the corrected bearings. That is, correct forebearing of line AB is equal to back bearing of line DA minus angle A. So here we have to take, that is back bearing of line DA. So we have started from the point at DA. So that is 306 degrees 40 minutes minus 180 degrees. So why we are taking here 180 degrees? Because it is more than 180 degrees, that's why we are taking it as 306 degrees 40 minutes minus 180 degrees, okay, minus of 51 degrees 40 minutes. So this is the angle A reading which we got the corrected forebearing of line AB in that interior angle, okay. So then we will get, with this, if we do minus 306 40 minutes minus 180 degrees, we will get 126 degrees 40 minutes, okay, minus of 51 degrees 40 minutes, then we will get 75 degrees 0 minutes. So this is the first one of corrected forebearing of line AB, okay. So meanwhile the correct back bearing of AB, okay, we have seen now correct forebearing of AB. Now we have to see the correct back bearing of AB, that is 75 degrees 0 minutes plus 180 degrees. So why we are doing here the addition? Because the back bearing of AB is less than 180 degrees, okay. So that's why we have to add the 180 degrees, then we will get 255 degrees 0 minutes. It is the back bearing of correction AB. So the next we go, forward bearing of line BC is equal to back bearing of line AB minus angle B. So again we have to take the, so that means in the opposite, okay. So if you go, that is, suppose you see here the station point A, this is the station point A and this is the station point B. In meanwhile, like this the diagram, this is the C and this is the D. So this is our diagram is there. So here we are seeing that is forebearing of line AB, that is nothing but back bearing line of AB. So if you see here, this will be the forebearing of BC, and if you see here like this in the anti-clockwise, it will be the BA, okay. So forebearing will be BC, but back bearing will be AB. So that's why we are taking here back bearing of line AB is 255 degrees. So that is we got here, that is the correct back bearing of AB. We have to take this one correct back bearing minus of angle B, we got 148 degrees 40 minutes. That is the where angle we have got at B. So this is equal to the BC, forebearing of line BC we got now how much? 106 degrees 20 minutes. So this is the correct forebearing of line BC. So whereas then correct back bearing of line BC is equal to, okay. So what we have to take, that is forebearing of line BC, okay, forebearing of line BC plus 180 degrees. How much we will get? 286 degrees 20 minutes. So because it is less than 180 degrees, we are taking the 180 degrees angle. So now forebearing of line CD is equal to, okay. So forebearing of line CD means this is the forebearing. Now here up to forebearing of line CD, then what will be the back bearing? That will be the back bearing of line BC. So this is the line you will be. So from here it will be saying this back bearing. So the back bearing of line BC minus angle C, we will get 286 degrees 20 minutes minus of 61 degrees 30 minutes. You will get the answer as 224 degrees 50 minutes. Okay. In this way we have to calculate the problem. So finally the back bearing of line CD is equal to 224 degrees minus 50 minutes minus 180 degrees. So why we are doing 180 degrees minus? Because it is the answer more than 180 degrees we have got. So we will get answer is 44 degrees 50 minutes. So finally, forward bearing of line DA is equal to 360 degrees minus angle D plus of back bearing of line CD. We will get 360 degrees minus angle D 98 degrees 10 minutes plus 44 degrees 50 minutes. The answer is 306 degrees 40 minutes. So finally we got the at the station point DA is 306 40 minutes what we have checked in the question, and bank bearing of line DA is equal to 306 degrees 40 minutes minus 180 degrees, because more than 180 we got 126 degrees 40 minutes. Finally, the corrected bearings are this one: AB, forward bearing and back bearings. So summary, today we have seen, in this class we have learned that local attraction, sources of local attraction, detection of local attraction, elimination of local attraction by different methods. So in this way we have to calculate the local attraction problems. Okay, I think everyone understood. Thank you. Have a nice day.